All right, let's look at this 9.74. So for this circuit, there is a K, and we don't know how much is that. So we can just this K so that ZAB is purely resistive when omega is a 4,000 reading per second. Find ZAB. Okay, so the idea to find ZAB is the impedance look from AB to the right hand side. Okay, so the equivalent circuits look like this. So we want to reflect everything on the secondary to this particular impedance, the reflect impedance ZR, and combine with the existing ones, so we can got this ZAB. And we want this ZAB is pure resistive. That means there's no imaginary part, and we can find that K. Okay, first thing, we want to bring this whole circuit into a phasor domain. So the inductor L1 become J omega L1. Okay, so we have all these numbers based on that, and the M, the mutual inductance, M equal to K L1 L2 square root. Okay, and then we just put numbers here. So there is a 10 to the order negative 3. There's 8 multiplied 10 to the order negative 3. So we can put this one outside of that square root. And things, if you remember from last video, the reflect impedance equal to omega square M square over Z22. Okay, Z22 is all the impedance A together. On the secondary side is also have the equation for this one, but in this particular case I find this one is easy to calculate. And then let's do that. We need M square, so M is this one, M square is just K square, and this square root is gone. There's 10 to the order negative 6, and I multiply with omega square, so omega square is 16 times 10 to the order of 6. So negative, positive cancelled, then this 1600 K square for the numerator of this reflect impedance. Z22, again, let me shrink a little bit. So Z22 is everything in the right hand side. Is a 5 plus J32 plus or minus this J20 equal to 5 plus J12. Okay. You can follow this one, or you can directly using this one divided by this one. Okay, I have all the impedance right down here. So you find this reflect impedance equal to 14.3 K square minus this one, and you will, because it's a pure resistive, okay, because it's a pure resistive, this is a ZR. So ZAB, you need to plus this 20 and J50. Okay, so if you plug this ZR into here, and ZAB is pure resistive, so this two part should equals to 0. Okay, so if you combine that one, let's finish this part. If you combine that, you got 20 plus 47.3 K square. That's the real part. Okay, that's the real part. And plus a J. Here is 50 minus 113.6 K square. That's the imaginary. Okay, for this imaginary part, should equals to 0 because it's pure resistive. So 50 minus that one equal to 0, then you can solve that very easily. K equals 0.66. Okay, and this ZAB is a pure resistive 40.83 omega here. Okay, that's it for this question.